Yes, we can.
All right, thank you. So let's start. Let's keep going. So give me a minute. All right. Moving on to this question here. We have, please mute yourselves if you're not asking a question. Right. Guys, please mute yourselves. Okay. So we have the function f of x is equal to 1 over 2x minus 4x, right? And we asked to differentiate that. Clearly here you see you can apply the quotient rule. So let's just copy the quotient rule once again and then apply it to our problem, right? So when you apply the quotient rule to this problem, what do we get? Let me just rewrite it. So our f of x is 1. Our g of x is 2 sine x minus 4 cos x. Okay, so what do you get in the numerator? I want you guys to tell me. Just apply the quotient rule. I want you guys to attempt and then tell me what you get.
I think we get minus 2 cos x plus 4 sine x. Hi.
So minus 2 cos x
Plus
4 cosine x. Sorry, 4 sine x, you said.
Yeah.
Okay, does everyone agree?
Yes.
Yes.
Okay, let's check that. So our f of x is 1. So when you take the derivative of f of x for the first part here, you have 0. So this first part is eliminated. The second part now will be minus. Okay, remember there's a minus there. The derivative minus f of x, which is this 1. So minus 1 multiplied by the derivative of the denominator, g of x. So what's the derivative of 2 sine x? It's just 2 cos x. So you have minus 2 cos x. But what's the derivative of minus 4 cos of x? The derivative of minus 4 cos of x is plus 4 sine of x. So when you have minus 4 sine of x there, okay? So you need to be careful with the signs. Does everyone understand that?
Will it not be positive still?
No, it wouldn't, because look, if you do, let's just take this and copy it here. And then let's see what we're getting. And then, of course, the g of x is just 2, let me just write that, 2 sine of x minus 4 cos of x. Right, so remember, we said this first part here is equal to 0. The second part is basically f of x is 1, so we can write it or leave it. And then we have the derivative of, so we have 0 minus the derivative of what's in the denominator here. So the derivative of 2 sine x is 2 cos x. And the derivative of minus 4x is
never mind.
plus
Okay.
4 sine of x. Right, so now when you apply this negative sign to what's in under the bracket sign, then that's when the negative comes from. So I hope it makes sense.
Yes, it does. Thank you.
Okay. So any other questions there? And of course, you can simplify this expression further if you want. I'm not sure if there is a way to simplify it, but I think it's fine this way as well. Maybe you can take out the 2 and simplify it on the denominator and numerator. You can try that on your own. But this is basically the answer that you should get. Right? So moving on to sub questions.
We also could, sir,
yeah.
we also could use the chain rule, right?
For what? For this question?
Yeah.
No, I don't see how you would use the chain rule for this question yet.
Was to raise the whole thing to like -1.
Okay, well,
see, I promise.
yes.
I used the chain rule and I got the same answer.
Okay, yes, you could do that as well, but yeah, I think yes. If you get the same final answer, then it's fine. Yeah, I don't see a problem with using it that way. It's just that for this particular example, I wanted to use the quotient rule, but you might as well just also use some other rule that you know. But as long as it's you sort of like you pay attention to the calculations that you actually are doing, so you should get the same answer. Okay, so if you did get the same answer, then it's fine. I think, at least that's my opinion. I'm not sure if in the test or anything like that, they will give you a specific rule that you have to use. But on my side, it's perfectly fine. Okay, so for the second one, yeah, well, it's basically the same as the first one, quotient rule, right? So for the sake of avoiding repeating the same thing, I'll just leave you guys to do this one because this one is easily done based on what we did for the first one. So let's choose one that we haven't done, which is the third one. So here we're trying to find the derivative of f of x, which is equal to 2e to the x minus 8 to the x. And here we'll remember the we'll remember the expression that tells us, it's sort of a general rule as well. Remember that when you're trying to find the derivative of some constant a to the exponent of x, okay, you have that it's equal to the same thing, so you rewrite the same thing, a to the x, right? Then multiplied by ln of of a, right? So now you can generalize this to be a to the exponent of any function. So let's say any function f of x. It could be x, it could be 1, it could be 15x, it could be any, as long as it's any function in f of x, right? Please mute yourself if you're not asking a question. Thank you. So it will be the same thing again, f of x now multiplied by the derivative, sorry, a to the f of x multiplied by the derivative of f of x multiplied by ln of a. Okay, so this is sort of the general form of the expression. All right, so now if you apply it to our problem here, right, then what you have is, let's just rewrite that. You have now two functions. You have the 2 times e to the x minus 8 to the x, right? And you're trying to find the derivative of that, right? So what is that equal to? First, you find the derivative of the first part here, which is 2ex. What's the derivative of 2ex, guys?
Isn't it 2ex?
Yes. Does everyone understand that?
Yes.
Okay, so 2ex minus, what's the derivative of 8 of x?
It's
8
8 exponent
a
8
Sorry?
exponent x ln 8.
Yeah. So 8 to the x ln 8. Does everyone understand that?
Oh,
You don't understand that? Okay. Let's just use the identity, the expression that we have here. In our case, a is 8, right? So just substitute a by 8, and f of x is just x. So you retype the original function, which is, so the derivative of 8 to the x is just 8 to the x again, multiplied by the derivative of f of x, which is in our case x. So the derivative of x is 1. So 8 to the x times 1, multiplied by ln of 8, which is what we have here. So it's a pretty simple, straightforward expression. Okay, so now let's look at question 4, where we'll be using the product rule. So let's go back to our product rule here. Let's copy it and then bring it down here. So we have our product rule tells us that. So when we are trying to find the derivative of, right, 6 plus 4 square root x times cosec x we have to first find the derivative of the first part. What's the derivative of 6?
0.
not
0. Plus the derivative of the second part, which is 4 times square root of x times cosec of x, right? So here, that's where we will apply the product rule. So apply the product rule and tell me what you get.
2 over root x square root of x times cosec x minus 4 square root of x times cot x cosec
So
x.
you said 2 over root of x right?
times,
Times cosec x, right?
yeah,
And then minus,
4 square root of x.
sorry, 4. Oh,
Square
okay. Oh, you took, okay, let's take out the 4 outside first. And then what?
times cot x cosec x.
So square root of x times what? Cosec x.
Hold on. I don't know about that 4 you put there at the very front.
Oh, no, I just took it out of the bracket sign,
Oh.
so it doesn't, yeah.
And
There's
then
a bracket.
cot as well.
And then cuts.
Yeah.
Okay. So let's double check that. Does everyone agree with her? If you don't agree, just attempt it on your own and see. I'll give you like 2 minutes to check.
Jonathan,
Yes.
that 4, I think it's supposed to be 2 over root x cosec x minus 4 times root of x square root of x cosec x cot
Oh,
x.
okay, so you already multiplied in the 4. No, that's fine. So you mean like this.
Have the 4 there and not there, yeah.
Okay. Guys, try it then and double check.
That looks about right.
Looks about right.
It's correct.
Did you attempt it and did you get the same answer?
Yeah.
Yeah.
Yes.
I see a hand raised. Please unmute yourself and ask the question. Okay, I guess it must have been an accidental hand raised. Okay, so if you all of you guys agree, then it means we are on the right track. Okay, so can you simplify this any further? I don't think you can, but okay, maybe you can take out the 0, and then you have basically this here comes back, and there you go. So that should be the answer that you get. You can double check all the calculations and see if you get the same thing. So now let's move on to something a little bit more challenging, right? So let's look at question 5, which is a bit more challenging for us. Let's find the derivative of this entire expression here, f of x. And just write it. But in the meantime, you guys can start solving it, and then we'll check the solution together. So attempt question 5 on your side, and then let's do this.
Sorry, sir, is that negative 2 fourth root of x or what?
It's -2. Yes, the fourth root of x, if you want.
Oh, yes, thank you.
Yeah. So I want you guys to attempt it and tell me what you get. 2 more minutes.
Is it 1/2? 1/2 x raised to negative 1/2.
Sorry, 1/2.
X raised to negative 1/2 plus
1/2 multiplied by x to the negative 1/2.
1/2 x raised to negative 1/2 plus
Okay.
8/3 x raised to negative 2/3 minus 1/2 x raised to negative 3/4.
X to the negative 3/4. Okay. Anyone else? I wrote down your answer.
I got 1/2 root x
Yeah.
plus 8/3
Mm-hmm.
cube root of x squared
Mm-hmm.
minus 1/2 fourth root of x cubed.
4 roots over 2 fourth root of x cubed. And all of these roots are in the denominators, right? For your answer.
Yes, on in the denominator.
Yeah. Okay. Anyone else?
Yeah, the same answer. So yeah.
I also
What?
got the same answer. I also got the same answer as the one raised by the first one.
Okay, so basically all the answers are that were given are the same. Okay, so you had 1/2 multiplied by the square root of x, right? Plus 8/3 multiplied by the cubed roots multiplied by the cubed root of x squared, right? And then minus 1/2 multiplied by the fourth root of x cubed. The fourth root of x cubed. So all those answers that you gave were identical. Well, both similar, right? So yeah, that's it. Does everyone understand this?
Yes, sir.
All right. So
Easy peasy.
moving on. Let's look at question 6, where now we have the logarithmic functions coming in. So let's make some room and then let's copy our logarithmic expression that we had.
Hello?
Yes, yes.
I'm struggling to see your screen. I can't see your screen. I exited by mistake. Please, can you like try something? I don't know.
You can't see my screen. I feel like it's, I don't know why it does that. Okay. Let me just quickly copy what okay, yeah, there it is. Wanted to do, and then put it here. And then let me stop sharing. And then let me start to share again. Hopefully that solves the issue. I have so many windows open. Wait. Sheet. Okay, there you go.
Thank you.
So just give me a minute to check my Teams. Okay. I hope you can see my screen now. Right.
I can.
Okay, so moving on. So now we're applying all what that we've done to logarithmic functions. So, and we have our identity here. So now let's apply it to a function that has two logarithmic expressions. And let's see what we get, okay? So we have to find the derivative of 4 log to the base of 3 of x minus ln of x. And what's the derivative of that?
It's 4 over x ln 3 minus 1 over x.
Sorry, 4 over
X 4 over x times ln 3. 4 over x times ln 3
and then, okay,
minus 1 over x.
minus 1 over, okay.
1 over x.
Okay, does everyone agree there?
Yes.
Okay, does any,
Excuse me,
sorry? Go ahead.
the general rule for deriving logarithms.
Sorry?
I was saying, please may you explain the general rule for
Okay, the
logarithm.
general rule.
Yeah.
Yes, I'll do that just now. Okay, so let's take, let me just copy the ln, because ln is a specific portion of the general rule, right? But the real general rule is that when you have, just copy that and paste it there. Yes. So when you have the logarithm of some function f of x to some base, let's generalize and just say some base a. A can be any integer, right? The same, and you're trying to find the derivative, the same expression applies, but now in the denominator, you add ln, right? You multiply it by ln of a. That's the only difference, right? And it sort of makes sense. Why? Because remember that ln of x is just basically log of x in base e, right? So for the ln function, a is equal to e. And you know that ln of e is just 1. So that's why the ln doesn't apply there. So basically, if we wanted to be really general, we could just write ln of e in the denominator there, which is just 1, right? So we don't write it. That's why we don't write it, because it's just equal to 1. Okay? I hope that makes sense. So can you guys, do you guys want to sort of try it for like 1 minute and then tell me what you get, if you get the same thing as the other guys?
Yes, please.
Yes, okay.
Yes, okay.
Yeah.
So I'll give you 2 minutes, try it, and then tell me what you get using the formula that I just gave you guys. Right. Does everyone agree with the answer that was given? Let me just write it down so you guys can check.
And answer is right.
Oh. So everyone agrees with this answer?
Yes.
Yes.
All right, thank you. So now moving on. Let's
sorry, can you
Mhm.
please explain on the can you please explain how it goes 1 minus 1?
Sorry, many people are speaking out at the same time. Just can you repeat that again slowly? Because there's interference. I don't know if it's the wind.
Can you
Go ahead.
please explain the parts where you put minus 1 over 8? How you
What?
arrive?
Sorry, which parts? This part here, 4 over.
No, where you go to minus 1 over 8.
Minus 1 over x, yes, this is the derivative of ln of x. The derivative of ln of x is just 1 over x. That's sort of like a general because if you look at the rule here, when you have the derivative of function, you just take 1 over that function. In our case, it's x, so 1 over x multiplied by the derivative of the function, multiplied by the derivative of x, which is just 1. So you have 1 over x multiplied by 1, which is just 1 over x. I'm not sure if that answers your question.
Yes, thank you. Thank you.
All right. So now,
Can you please explain the first part?
this first part here, you use this general formula here for logarithmic functions. And to be honest, like I said, the first formula here for ln comes from this general function here. Okay, so you can sort of derive it from that. And it basically says that when you have the logarithmic function, the logarithm of a function f of x to some base a, that you take 1 over f of x multiplied by, excuse me, the ln of a, right? And then this whole thing multiplied by the derivative of f of x, right? Applying it to our case, our 4 is a constant, so 4 comes back. The derivative of log in base 3 of x is just then 1 over x, right? Multiplied by ln of a, which is ln of 3, right? Multiplied by the derivative of f of x. The derivative of x is just 1. So you have 4 over x times ln 3 multiplied by 1, which is just 4 over x times ln 3. Does that make sense?
Yeah, okay, thank you.
Right. So now let's apply this again. Now we'll be applying the product rule and exponential and logarithmic rules to our expression here. So apply it to question 7 here and tell me what you get. I'll give you guys 5 minutes.
Is it
Go ahead.
3 exponent x? Is it 3 exponent x ln 3 times
no.
log x?
Wait, sorry. Just give me a minute. 3 exponent, let me write that down. 3 exponents x
Ln 3
multiplied
times log x
times log x. That's the answer you got.
plus
Plus
1 over x ln times 3 exponent x
sorry, plus 1 over x
in 10
plus 1 over x times
ln 10.
ln 10.
Yeah.
And
Times
then
3 exponent x.
Times 3 exponent x. Okay. So I got your answer. Now, does everyone agree with that? Let me write it down, maybe so you guys know what he said. So 3 to the x, 3 to the x times then 3. It's just times log x plus basically 3 to the x divided by x ln 10. So
Yeah, that's correct.
Yes.
do you guys get the same answer? All of you guys.
Yeah.
Does everyone agree?
Yes.
Okay. So now let's move on, if there's no questions, to the chain rule. Let's move on to problems with the chain rule. So for the chain rule, we have a function, our original function here. Obviously, we'll use the product rule as well, because you have the product of two functions, right? So for our first question here, you have f of x is equal to x squared times ln of x to the 5. And you are asked to find the derivative of this expression, okay? So there are multiple ways you can go about this. What I want you guys to apply is the quotient rule. So apply the quotient rule and the chain rule, basically, and see what you get.
Should we give you the answer already?
If you do have it, I mean, you can give it to me and I'll write it down and then we'll check it.
Okay, so we have 2x times ln x5 plus x to the negative 3
Sorry, x to the negative 3
times 1 over x5.
times 1 over.
Okay, that sounds so wrong. Never mind.
Okay, try again and let me know.
Over
Sorry. One at a time, please. One at a time.
I think it's
Go ahead, guys. One at a time.
We have 2x ln x to the 5 plus
Okay.
5x squared.
5x squared.
No, it's just plus 5x.
Oh, that's it.
Yes, that's it.
So 2x times ln to times ln of x to the 5
Yes.
plus 5x squared.
No, plus 5x.
Plus 5x. Okay. Plus
Yes.
5x. Okay. Does everyone agree? Let me write it down so it's clear. Times ln of x to the 5 plus 5x. Does everyone agree? with that?
No.
Did you say which rule did you
Wait,
say we must use specifically, or
they
does it
said we
not
must
matter?
use a chain rule.
You can use the chain rule, or you can, okay, so in a test setting, if they ask you to use a specific rule, use it. But just for the purpose of this session, maybe you are free to use any rule as long as it makes sense, right? So maybe try the chain rule, and then try any other rule that you have in mind, and then see if you get it. Because you should get the same answer. The rule is just arbitrary because it should give you the same answer at the end of the day.
Sorry.
Yeah.
I used a chain rule, and
Yes.
that answer is totally different from mine. The first part is right, but the plus 5x.
Me too.
Sorry.
So don't you get that from times in like? Don't you get that? Don't you get the 5x from times in x squared times 5 over x? Because I used the product rule and my answer was like x squared times 5 over x.
And that's all you got.
2x.
Okay. Let's go through it. Let's go through it then. Okay, so everyone agrees about the first part.
Yeah.
So
the first part
Yes.
is right.
So the second
The
part
whole
is
thing is
basically
right, sir.
the whole thing is right, but I just want to check
Okay.
the second part here. You're asking, you're trying to find out basically it's x squared, right? So let's write it down. Let me just add another step in between here. So you have the first part is right, 2 ln x to the 5. Now the second part is basically x squared, right? Remember, that's what f of x multiplied by the derivative of ln of x to the 5. Now, if you use the rule that we used for some function, so let's just copy that and place it here so we can see it. So now, if you use this rule for the derivative of ln of x to the 5, what do you get? Well, you get that you get 1, right? And so you just multiply that. 1 divided by x to the 5, right? Multiplied by what? Multiplied by the derivative of f of x, which is x to the 5, which is 5x to the 4. Right? Okay. So now, what happens in here? You have in the numerator, you have x squared times 5x to the 4, which is 5x to the 6 divided by 5x to the 5. Oh, sorry, 5x to the 6 divided by x to the 5. And that's where you should get 5x. Does everyone understand that? When you simplify the x.
Where is 5x to the 6 coming from? So
Okay, let me write that down. Let me write that down. So let's copy this and write it down. You have x squared multiplied by 5x to the 4, right? So you can take out this x squared and just write 5x to the 6. Does that make sense now?
yes, thank you.
Okay, does
I just
everyone
forgot this expert.
yeah, does everyone understand that?
Yes. Can you just like if you define the chain rule, right? And then it's gonna be the derivative of the outside function. times the inside function times the derivative of the inside function. It's slightly different because I guess to establish, to get this answer, we use product rule.
We use product rule, yes, but
Yeah.
also the fact that you do have this technically, you know that this is a sort of a chain. You start with the outside function, right? Look, ln of f of x, the outside function is ln. You start with the derivative of that, right?
Yeah.
Which is 1 over whatever the function is.
Mm.
And then you take the derivative of the inside function, which is f of x. Does that make sense?
Yeah.
Yeah. Same applies here. So basically, these are, especially for the general cases, right? These are all basically sort of chain rules. Let's look at something maybe that we used again. Something like let me see. Well, I can't find any other expression that, but especially ln, the ln function tells you, sort of shows you how it's a chain. So you go from the outside to the inside. So if you applied the same concept, you would get the same thing, because basically what you're doing now is ln of x to the 5. You take the derivative of the outside function, which is ln, which would give you 1 to the x5, right? Which is 1 to the x5, multiplied by the derivative of the function, the inside function, which is the derivative of x to the 5, which is 5 times x to the 4, right? Which is what we have here. But remember, we have the x squared coming from the other function here. So when that multiplies with the 5x to the 4, you have 5x to the 6. That can then cancel with x to the 5 in the denominator to get 5x. So I hope that makes sense for everyone.
Yes, thanks.
All right. So moving on to this one, which is a real, like, now you can see how the chain rule is applied here. So what do you get when you apply the chain rule to this? So I want you guys to attempt it. Let me know what you get.
I get a negative sign.
Wait, give me a minute. Give me a minute. So I can write that down on paper. What did you get?
Negative sign into like x squared times like times e exponent x, and then times 2x 2x times e exponent x plus x squared times e exponent x.
Okay. Are you putting brackets into it somewhere there?
Yeah. Yes.
Okay. Okay. All right. What does everyone think? Let me write it down.
It's correct. It's correct.
X squared e to the x multiplied by 2x e to the x plus x squared e to the x. Everyone agrees here?
Yes.
Okay. Everyone understands? All right. Let's move on. Same now applies to this specific function now. Try the next one and tell me what you get. Sub question 3.
We have, can you hear me?
Sorry, can you repeat that again?
We have 2 cos
2 cos.
3 inside bracket 3x plus 10x,
Mm-hmm.
then times outside 3 plus 6 squared x.
Sorry, plus times
Where? Okay, did you close the
times.
bracket? Plus x.
Sorry, repeat that again, please.
Let me start over again for you. So we have 2 cos 3 plus 10x.
Mm-hmm.
Close the bracket, open another set of brackets, 3 plus 6 squared x.
3 plus 6 squared x. Okay. So does everyone agree here? Let me write it down.
Yes. Incredibly
3x
correct.
plus 3 times 3 plus sec squared x. So does everyone understand where that comes from? Is there a problem with this, or can we move along? And just to sort of mention it, this is not under the cosine sign. Let me just put it out so people don't confuse it. Okay, so everyone agrees?
Yes.
Perfect. Okay, moving on to the last set of questions, asking us to solve these problems using implicit differentiation. And just as a reminder, implicit differentiation means that you're differentiating y in terms of x. Okay, so you guys have done implicit differentiation. So I want you guys to attempt the first question and tell me what you get.
We're looking for dy over dx, right, sir?
Yes, so
Also, so it's 1 over.
let me just write it down. So basically,
1 over.
find dy over dx. So what is dy over dx in our case?
Is it 1 over 3 y squared?
Let me just write it down and then people will discuss. So you say 1 over 3 y squared.
Y squared.
Okay, does everyone agree there?
Yes.
Are you certain?
It's correct. Oh, hold on.
Just double check. And everyone else keep trying. Remember, we are using implicit differentiation here.
Yes, same as like we used quotient rule. So
Not
we
the
leave the
same. No,
first.
no. Not the same as when we use quotient rule. It's not the same thing.
So
Yes?
I got y squared over 3y squared times x.
Oh, sorry. Repeat that again. You said y squared.
Yeah, over
Mm-hmm.
3
3
y squared times x.
y squared times x. Okay.
Hold on,
Does,
just
does everyone
I
agree?
have a question.
Also can
Are we
and
allowed to multiply the 1 by the y cubed?
Yes, yes.
then
That's what you found. That's what you found. So guys, keep attempting. And sorry, sorry, go ahead. Can you repeat that again? Okay, so I can see you guys are attempting. So let's solve the first one and then maybe it will make sense for the other ones. Okay. So you're trying to find dy over dx, right? Obviously you have x over y cubed, so you can rewrite this, right? You can rewrite this as x is basically equal to y cubed, right? And remember, you're trying to find the derivative of y in terms of x, so you need to have y on that side. So you need to have y without the exponents, basically. So what you do is you take the cubic roots on all sides. Okay, so let me just copy the cubic sine root. So you take the cubic roots on all sides, and you have now y is equal to the cubic root of x. Okay, and now when you derive this expression, copy that again. When you derive this expression, you basically have y prime. Okay, so you have y prime, which is the same as dy in terms of x. So dy dx is equal to the derivative of the cubic root of x, which is 1 over 3, right? Times times cubic root of, let me copy that, times cubic root of x squared. You guys understand this?
yes.
Because
Hold
remember,
on.
you're
Y
trying to
cubic root.
have, sorry, go ahead.
Y cubic root, why isn't that first answer that we gave you 1 over 3y squared correct?
Because you're trying to find the derivative of x, of y in terms of x. So it should be in terms of x. You can't have a y there then. Okay, I don't know if it, you can have a y, but you should have an x as well.
Okay, so when, from that
Go
first
ahead,
step, that x is equal to y cubed.
sorry?
From the first step that you wrote down, the x
Yes,
is equal to y cubed.
yes.
From there, if we apply the implicit differentiation, don't we have 1 is equal to 3y squared times dy over dx?
Okay, let's do that. Let's try. So you're basically saying, let me copy that. You apply implicit differentiation. You have dx is equal to 3y squared, and then you said dy over dx. Okay, that's what you said, right?
Yeah. Yes. I
Okay,
said y. But yeah, cool. I guess.
you get
That
it
also
now. So the problem is now you have two dx's.
Yeah.
So when you take it to the other side, basically what you're having is, remember, you're trying to find dy over dx, right? So
Yeah.
if you take it to the other side, what do you have? Let me just simplify this. So basically on the right hand side now you have dx squared.
Okay.
Right? And on the right hand side you have 3y squared dy, right? Which is, remember, you're trying to find dy over dx, not dy over dx squared. I'm not sure if it makes sense. So that is where, that is why you're trying to get rid of the cubic sign there, right? To simplify the expression in such a way that you can have y expressed in terms of x, and then you can derive that, and then you get a nice looking expression dy over dx equal to some function in x. Oh, and just to clarify, there could be y as well here. Just like we'll see in the other cases here, there will be y showing up, right? So it's possible on the right, sorry, on the yeah, on either side of the equations, right? So there will be y showing up. So you will see that it does happen. But for this case, we are trying to find dy over dx specifically. So we should avoid having something like dy over dx squared, right? Which is not what we're trying to find. So okay, now attempt question 2. Tell me what you get.
Okay, I have dy over dx is equal to minus 3 cos 3x.
Wait, sorry, let me rewrite that. Dy over dx is equal to
Negative 3 cos 3x
minus 3 cos
3x divided by
cos 3x
over
divided
14y
by
Justin, write that question. Okay, this
14y plus 4y cubed
14y plus 4y
y cubed.
cubed. Okay, does everyone agree with this?
is
Does anyone have a question? Okay, so I'm assuming everyone understands that. So moving on. Attempt question 3 for me and tell me what you get for dy over dx.
Hey,
Sorry, go ahead.
sir, sir,
What you get?
sir,
Mm-hmm.
I don't understand at number one. Uh, the answer you got was 1 over 3 roots x squared.
Mm-hmm.
So yeah, then I got 1 over 3 exponent 6. Why did you
Wait, sorry.
exponent 6?
Where's the 6 coming from?
So I don't know if I'm correct, but we dy over dx should be equal to 1 over 3y squared, right?
No, it should, well, no, because you remember, okay, so you cannot have, basically, you should have y expressed in terms of x. So when
Yes,
you're trying to
I'm
solve,
guessing there.
okay, go ahead.
That's why we substitute the inverse of the original function.
Okay, so wait, I think I see what you did. Okay, so walk me through the steps. So you started with this first step here.
Yeah.
Okay, then what did you do? You took the cubic root.
Yes.
To this step.
Yeah.
Okay, and then?
Then I made an inverse of this one.
And why did you take the inverse? You don't need to take the inverse.
And that's the rule for the implicit is that's the f of the inverse of the function.
Okay, wait. So we're talking about implicit differentiation, not implicit functions. So there's two different concepts there. Okay. So what I would advise you is not to combine them, because then it might confuse you when you're doing the calculation. So you might get some wrong answers along the way. So try to solve it this way. Yeah, keep it. Don't try to look for the inverse or anything like that. Okay, so try to keep it as close to the original function that you are given as possible, so that you can avoid mistakes along the way when you are calculating.
Okay, thank you.
Yeah. Anyone else?
Sir.
Yeah.
Can you please repeat number 2?
Number 2, you're taking number 2, you're taking the derivative of y in terms of x. So let's sort of write it down and then see what we get. Okay. I'll just write down the first step and then you can simplify from there. So let's derive the first one. You have 7 times the derivative of y squared, which is just 2, right? So it's basically 2y dy over dx. Remember, you're deriving in terms of x. Okay. Plus the derivative of sine 3x, which is basically 3 cos 3x, plus, equal to the derivative of 12, which is 0, minus the derivative of y to the 4, which is basically 4y cubed times dy over dx. Right. So as you can see, let me just take out this here and put it out here. And then let's take out the 2y and put it across there. So you can clearly see that dy over dx is a common factor between these two terms here. Okay. Do you understand that?
Yes.
And then, so what you do is just combine now the 2 dy over dx, and then you take dy over dx as a factor. You factorize, and then you take this 3 cos on the other side, which is that, and then you divide by the factor that you get when you factorize these two terms in dy over dx. Basically, you're making dy over dx the subject of the equation, if it makes more sense that way. Yeah. Okay, does that make sense? Do you understand?
So how will I able to factor the dy over dx while there is a plus 3 cos 3x?
Okay, wait, so you're factorizing the terms that are the same. You have dy over dx here and dy over dx here. So you can take this term, this whole term here, to this other side here, and then factorize it with this other term, not with this, because this term 3 cos 3x doesn't have a factor of dy over dx. Does that make sense?
Yeah.
Yeah. So that's what you do, and then you should be able to get this answer. Same applies for this one here and the next one as well. Okay, so I want you guys to attempt that because we ran out of time. I have another session that I have to attend just now, so I want you guys to attempt it, and then